Welcome to Math 1960 Calculus 2. This is UNO summer session number 3. So today we're going to discuss improper integral. So any integral that involves infinite limit, like negative infinity to a certain number, maybe b f of x dx. So a to positive infinity f of x dx, or -3 to 3 of 1 over x dx. These are all called improper integral. Here at point 0, this function is undefined, and we are integrating from -3 to 3. So 0 is inside this interval, and this interval here has infinite limits. So these are all known as improper integral. So today we're going to learn about this improper integral. Okay, so the best way of learning mathematics is to do problems. Okay, so here I want to integrate the function from 1 to infinity 1 over x dx. So first of all, in order to integrate this function, I'm going to say limit as b goes to positive infinity. And then now I'm going to change the limit of my integration from 1 to b, from 1 to b. And then I put the integrand 1 over x dx. Okay, now it's easy to integrate. This is what I'm used to. Once I'm done with integration, then I can evaluate the limit. So I know the integration of 1 over x is going to be ln of x. So I have limit as b goes to positive infinity of ln of x, evaluated from 1 to b. So then I'm going to have limit as b goes to positive infinity ln of b minus ln of 1. ln of 1 is 0. So that means I have limit as b goes to positive infinity of ln of b. So b here goes to infinity. So when we take the limit at infinity, we're going to get infinity. So that means this function here, this integral here, diverges. So the other integral is integration of the function in part b, which is integration from negative infinity to 0 of e to the x dx. So we take the limit again as a goes to negative infinity. We change the limit of my integration to be from a to 0 of e to the x dx. So then what is the integration of e to the x? Is e to the x itself, right? It's going to be e to the x. we evaluate that from 0 to a. So then now we say limit as a goes to negative infinity of e to the 0 minus e to the a. E to the 0 is equal to 1. So then we're going to say limit as a goes to negative infinity 1 minus e to the a. So limit of 1 is going to be 1. Limit of this function here is going to be equals to 0. So then my limit 1 minus 0 would be equals to 1. That means this function here converges to a certain number. Okay, my other part C, we want to evaluate the integration from pi over 2 to positive infinity of sine x dx. Okay, we're going to use the same rule. We're going to change the limit of integration by using the limit. So here we're going to say b goes to positive infinity from pi over 2 to b from pi over 2 to b of sine x dx. So then limit as b goes to positive infinity, that's going to be cosine x evaluated pi over 2 and b. So then we're going to have limit as b goes to infinity, so negative cosine b, because here cosine of pi over 2 is equal to 0. So limit of that does not exist. So that means this integral here diverges. Okay, we want to determine whether this integration that converges or diverges. So this integration can be partitioned into integral from negative infinity to 0 of 4x cubed dx plus integration from 0 to positive infinity of 4x cubed dx. So if any of these diverges, that means the whole thing diverges. So let's take this first. So let's take this integration first. So we're going to say limit as a goes to negative infinity of integral of a to 0 of 4x cubed dx. That gives you limit as a goes to negative infinity of x to the 4th evaluated at a and 0. So then when we evaluate that, limit as a goes to negative infinity of 0 minus a, so it's going to be minus a to the 4th. So when we take the limit of that, then we're going to get infinity. Yeah. So that means this diverges. This whole thing here diverges. So if this diverges, that means this also will diverge. So in problem, we want to find the area under the curve. So to find the area under the curve, we use integral. So we integrate the function from 0 to 4. So 1 over the square root of x dx. And then now we set limit as t goes to 0 from the right. So we have integral from t to 4 of x raised to the power of negative 1/2 dx. So then we're going to get limit as t goes to 0 from 0 from the right. That's gonna be equals to, so that's gonna be x raised to the power of 1/2 divided by 1/2, which is gonna be 2. So then when we this is evaluated from t and 4. So when we plug in this one here, we're going to get 4 minus 2 square root of t. So when we take the limit of that, square root of t, sorry. When we take the limit of that, we're going to get 4. So that means this is defined. We found so the limit is defined, or the area is defined. So here we're going to discuss this. So here determine whether integration from 0 to 2 of 1 over x minus 1 squared dx converges or diverges. So first, this integration, we're going to partition it into integration from 0 to 1 of 1 over x minus 1 squared plus integration from 1 to 2 of 1 over x minus 1 squared dx. So let's take this. If this one here diverges, that means the other one also will diverge. So at this point, we're going to say my integration, we're going to say limit as t goes to 1 from the left of integral from 0 to t of 1 over x minus 1 squared dx. So that would be equals to limit as t goes to 1. So then when we take the integration of this, we're going to get negative 1 over x minus 1 evaluated from 0 to t. And then we're going to get limit as t goes to 1 from the left. So when we plug in for t, we're going to get negative 1 over t minus 1. When we plug in for 0 here, we're going to get negative 1. When we take the limit of that, that's going to be equals to infinity. So that means it diverges. So one part diverges